Today we're going to be working on Leetcode question number 126, word ladder part 2. A transformation sequence from word beginWord to word endWord using a dictionary word list is a sequence of words. So it would be begin word, then another word, then another word, such that every adjacent pair of words differ by a single character. Every s of I between that list is in word list. Note that begin word does not need to be in the word list. Okay, the begin word does not need to be in the word list, and s of k is equal to end word. So the end word needs to be in the list. Given two words, begin word and end word, and a dictionary word list, return all the shortest transformation sequences from begin word to end word, and an empty list if no such sequence exists. Each sequence should be returned as a list of the word. So begin word and then all the sequences up until we get to the end word. And we can have, the tricky thing is that we can have multiple of the solutions, and we're gonna put all of them in. So there are two shortest transformation sequences. These are the two. Whatever are the shortest transformation sequences, we don't want to repeat them. We don't want to make the longer transformations, but however many transformations possible, the shortest transformation possible, we're gonna put them in the solution. Okay, and in the example 2 we don't have any, so we are just returning an empty list. So we're gonna be doing breadth first search here. In order to do that, initially we're just gonna be checking the sanity. We're gonna be doing the sanity checks. So let's say if uh, not end word, right, uh, or not begin word, meaning if they don't exist, or empty, or not word list. If any of these things are not given to us, or not in word list, what is not in the word list? Uh, Sorry, or end word is not in the word list, or the last thing we want to check is that uh, or we want to check that or the begin word is not is equal to end word, right? So if the begin word and the end word are the same too, in all these cases we're going to be returning empty array or a list. Return an empty list. Okay, now we're gonna have a variable which is gonna tell us how many words, what is the length of the begin word, like what are the total number of characters. So that would be the length of the begin word, and we have sure that all the words in the word list and the end word and the begin word, all of them, their length is equal. So all of their length is gonna be equal to begin word, like L. Now we're gonna have a variable which is gonna tell us like the we're gonna have a we're gonna see we're gonna have a dictionary where for every single word inside this the word list, we're gonna say what are the different possible uh, next forms we can have. So for that we're gonna say all combo dictionary. We're gonna say that this is basically equal to collections dot default. this is just a thing that collections default meaning, like if we are looking for a key inside that dictionary, if it doesn't exist, just create a new one with an empty list. So it's basically we're initializing the all combo list, like all combo dictionary, and then for every word inside this word list, we're gonna do is we're gonna check that there is one thing, and for every we also wanna, because for every index we wanna try to replace every single index. So for uh, I in the range of L, what we are doing is like we are checking every single word and replacing every single character one at a time uh, with with an asterisk and like uh, with an asterisk to kind of see what other words it can become. So all combo dictionary word. So we're gonna in order to make a different key, so for every single key uh, the trick is that we're gonna take that word up to I. So every, because we are actually, so so if we have a word COG, the keys we are making is asterisk OG, C asterisk G, and CO asterisk. These are the things we are gonna be making from COG. Okay, so in order to do that, we're gonna go over like colon I plus asterisk plus and the rest of the word for I plus 1, so on. So if that is the key, we're gonna say that we're gonna like we wanna check, and every single time we wanna append that our word. So for every single word, we are telling him that these are the different keys, and if it is already exists, we are actually gonna be appending that, and it's not gonna fail, because even if it does not exist, it's gonna create a new empty list. Okay, so just to be clear, in the end we're gonna have something like OG, which can have uh, a list of like COG and DOG and stuff like that, and we're gonna have other keys over here too. Okay, now once we are here, what we're gonna be doing is like we're gonna be initializing few things. Our answer is basically an empty list. Okay, and then we have a queue. We're gonna be using queue just like the collections dot queue, collections dot queue, sorry, DQ. Okay, collections.dq, and then we are gonna say that inside the queue we're gonna be appending things like what we're gonna be appending is for the begin. We're gonna start with the begin word, because in the BFS we start with the begin word, we take it out, we see all the things which we can get to, we put them in the queue, and so on and so forth. And then we're gonna say append and begin word. Okay, also we need a visited one, so that we can be sure that we have already visited it. Visited, which is basically a set of like begin word. set of a list, and we're going to be initializing a begin word that we know that okay, we have visited this one. Now while we have the queue, it's not empty, and the and not answer, and we don't have an answer yet. What we're gonna be doing here is gonna be saying that okay, let's say that the length is equal to the length of the queue. How many of them, because that many times you're gonna be popping the element from the queue. So how many elements are currently in the queue before even starting that, and the local visitor is like a set. We're gonna have a set, an empty set. Now we're gonna say that for however many like the elements were there in the queue, we're gonna do the processing. So for that we're gonna say for this in length, sorry, range of length. Okay. Now for however many were the elements inside the queue, we're gonna have few things. We're gonna have a word and a path queue dot pop left. Sorry, pop left. So because when we were pushing things inside the queue, we were pushing basically like multiple objects. We were saying that there are two objects. One is the begin word, which is just basically the string, and the other one is a list, which was initialized. Initially, we just put a list with one element in it, which is the begin word. And when we are popping it, we are removing one element, whichever was put first in it. So we are doing the pop left, and then it's going to give us two things again. One is the word, as we were putting it in, and a list, and the other one is going to be the path. Okay, now we're gonna say, because we have to make the same key for that all combo dictionary, we're going to be generating that. In order to do that, we need to have an index uh, for I in the range of L. For that, we're going to say that for next word, we're going to be creating a next word. Let me just write it down first. Next word in all combo dictionary. The word of, like, just like we created exactly like that, word of I plus ampersand plus word of I plus 1 column. So just like that, we're gonna say that the next word for all of those combination, like the, so basically we are actually going through all of the keys in the all combo dictionary. So if the next word is equal to the end word, then we're gonna just say that answer dot append, like path plus the end word. Okay, basically meaning that we found that. Okay, okay, and then if it is not, but then we also have to make sure that we already haven't visited it. So if next word basically not in local visited, right? So first of all, we're going to put it in local visited, sorry, dot add next word, and the other thing is we also want to put it in the queue, and the queue takes two things. The first one is the next word, and the other one is whatever was the current path, we're gonna add it to a next word. Looking good. Yeah. And the last thing we wanna do is like we wanna, because we have to kind of make a copy of visitor to the local visitor, whatever was the, so visitor had some things, right? Visitor is kind of a global here, so we're gonna do visitor dot union of whatever the local, oops, local visitor. So we're gonna whatever the local visitor was, we're gonna combine it. We're gonna take it and put it in the visitor too, and in the end we're just gonna return the answer. Looking good. Let's see. Oh, it should be the default dictionary. Sorry for that. So it is complaining that it takes one element. So in order to use two, I kind of have to do it like one element which has again two elements, two arguments, two different things basically. Now it is complaining that the DQ doesn't have an add. Yes, he is right. It should be append. So yeah. So a set has an add. Yes, but the queue has an append. Oh, again, it's gonna be like this. Let's see how it does for the other test cases. We are getting our time limit exceeded. Really? Okay. How can we fix that when we are returning empty at the beginning? If any of those cases, if we are like, these are the base cases, we definitely need to return empty. Then, oh, okay, we have a default dictionary. We are actually going through all the wordlist. Okay, now we have an empty, we initialize the answer as empty array. Then we had the queue. Okay, and then we appended it with the beginWord and the beginWord as a list, and we also say that we have visited, so we already put the visited in. Okay. So now then, as long as we have the queue and not answer, we're gonna do this. We're gonna check the length of the queue, and then local visitor is basically an empty set at the beginning. Then we are actually going through whatever is the however many elements were in the queue, and we are actually assigning the word and the path to the poplar. Sure. Okay, and then we have an I in the range like L, because we wanna create those keys with the asterisk signs. So we are saying that looking good so far. So if next word is equal to end word, we are actually appending it, the path and this one. That is good. If next word not n visited, right? Oh, this would definitely improve it, because we actually had to look for the not n visited. Yes, yes, it's definitely gonna improve that. And this time hopefully we're not gonna be getting, yeah, and the error. So this works.